encrypt everything, compute anything. That's what we're building with Arcium. So I'm Yannik, co-founder and CEO at Arcium. And today I want to introduce you to the technology that we're building and how it addresses some of the most pressing challenges in privacy and data security. So we are building the global supercomputer for a hyper-encrypted internet. So imagine a world in which any data can be stored securely in an encrypted way, while it remains possible to do anything with this data. A world where we can analyze, process, and learn from information without ever having to expose it. And so we are building the infrastructure and the technology to allow for this to happen in a trustless and efficient way. The way it works is that Arcium is a purely computational stateless network that runs entirely on encrypted data. And so we can have encrypted data that sits on Solana that enters Arcium. And then within Arcium, this encrypted data can be securely processed. And the way we are able to process this data is through cryptography, more precisely, secure multi-party computation. And the way it works is that encrypted data is being securely split into data shares, and those data shares can then be processed in parallel within the Arcium network. And so once those computations have been finished, encrypted outputs can be produced and settled back on Solana. And so Arcium becomes this autonomous asynchronous execution machine that allows for arbitrary computations to be executed on Solana. One of the innovations we've designed is ArcOS, the first decentralized encrypted operating system that powers Arcium. And on top of ArcOS, it's possible to deploy encrypted isolated environments, MXEs, MPC execution environments, which allow for the arbitrary processing of encrypted data. We've also designed our custom Rust compiler that allows arbitrary Rust programs to be compiled into a format that Arcium understands and can securely process. And with this compiler, combined with our frameworks, it becomes possible for developers to add confidentiality and security to their applications by simply deploying their apps in an encrypted environment. The most magical thing about our architecture, I think, is our cryptographic security model. And so where traditional distributed systems fail if a majority of participants become compromised, Arcium has security against a dishonest majority. So as long as there's one single participant that isn't maliciously collaborating, isn't compromised with all the others, Arcium can remain secure. And this cryptographic security model, however, doesn't come at the cost of performance. And so with our breakthroughs in MPC protocols, malicious behavior identification, and combined with GPU and hardware acceleration, we are 10,000 times, so many orders of magnitude faster than fully homomorphic encryption when processing fully encrypted data. Now, what becomes possible with this system is to build fully confidential on-chain applications and fully confidential off-chain applications. Arcium is a purely computational network. And so Arcium can be utilized to build confidential and efficient markets on Solana. Imagine Solana DeFi, but now fully encrypted and efficient. At the same time, it's possible to facilitate very data-intense applications. So to facilitate data aggregation or node authentication for deep-in applications building on Solana. And most impressively, I think, on a technological level is that we're able to allow for collaborative and federated learning within Arcium. So we've made significant breakthroughs in floating point operations and real number arithmetic that allows for many parties to run collaborative machine learning and fully encrypted AI models without having to trust any single individual. So those are just a few of the use cases that become possible with the kind of confidential computing that we are building with Arcium. Arcium is this dedicated network that developers can use to add confidentiality and encryption to the applications. Thank you.